Hello everyone and welcome to the channel. Today we're diving deep into the DNA of the modern digital world, the Java programming language. If you've ever used an Android phone, done online banking, or streamed a video on a major platform, you've interacted with a system powered by Java. For nearly 3 decades, Java hasn't just been around. It has been the backbone of global enterprise, providing the stability and scale required for mission-critical applications. It's an open source, uh, versatile, and continuously evolving language that remains one of the most powerful tools in a developer's arsenal. This video is your comprehensive overview from its revolutionary origins to its exciting, high-performance future. Why are we still talking about Java in 2025 when new languages seem to pop up every other day? The answer lies in its foundational promise: stability, scalability, and universality. Java is a language of giant systems, systems that cannot fail. We're going to break down the key technical concepts that make this possible, explore the massive ecosystem that supports it, and look at the cutting edge innovations that prove Java is not just surviving, but thriving. Prepare to understand why Java is still the number one choice for large organizations across the planet. Let's start with the basics. What exactly is Java? Fundamentally, it is an object-oriented class-based language. This means its entire structure is built around objects that contain data and methods, providing a clear, modular blueprint for massive applications. But its most defining characteristic is its philosophy: write once, run anywhere. How does this work? Unlike C or C++, which compile directly into machine code specific to your operating system and CPU, Java compiles its source code into an intermediate format called bytecode. This bytecode is not tied to any single physical machine. Instead, it is executed by a Java Virtual Machine or GVM. The GVM acts as a standardized abstraction layer. You write the code once and then the GVM translates that bytecode into native machine instructions specific to the operation system it's currently running on. This powerful feature guarantees unparalleled portability across any platform that supports Java. The story of Java begins in the early 90s, not for the internet, but as part of the Green Project at Sun Microsystems. James Gosling and his team were building a programming language for consumer electronic devices. The official release of Java 1 in 1995 coincided perfectly with the explosion of the World Wide Web, and its ability to run applets securely in web browsers made it an instant success. A major shift occurred in 2006 when Sun open sourced Java, leading to massive community contributions. Then came the era of innovation. Java 8, released in 2014, was perhaps the most transformative update, introducing functional programming concepts like lambda expressions and the stream API, fundamentally changing how developers write Java code. Today, under Oracle, Java is released every 6 months, ensuring rapid adoption of new features and keeping the language fresh and highly competitive. Beyond write once, run anywhere, Java's enduring success is built on three core pillars of technical design. Object-oriented. Java enforces OOP principles like encapsulation, inheritance, and polymorphism. This approach allows developers to manage complexity by modeling real-world entities, resulting in structured, reusable, and easy to extend code. Second, platform independent. This is the execution model we discussed. The GVM is the key. In standard, standardizes the execution environment, guaranteeing that your application behaves consistently, whether it's running on a powerful server cluster or a simple desktop. Third, secure and robust. robust. This is where Java truly shines in the enterprise world. Its robustness comes from automatic memory management, garbage collection. Developers don't manually allocate or free memory, eliminating the risk of memory leaks and segmentation faults common in C++. Its security is enforced by the GVM's architecture, which includes a class loader and a bytecode verifier that ensures all code is safe and valid before execution. This robust security model is why Java is trusted with sensitive data. To work with Java, you need to understand the relationship between the three main components of its ecosystem. Think of it as a supply chain for code. The GDK, Java Development Kit, is a complete manufacturing facility. It's what you install as a developer. It includes the compiler, the debugger, and all the tools you need to build your application. Crucially, the JDK includes the GRE. The GRE, Java Runtime Environment, is a delivery track. It contains all the libraries and resources needed to simply run a Java application. The GVM, Java Virtual Machine, is the engine of the truck. This small, crucial piece of software loads the bytecode, verifies it, and executes it, often optimizing the code on the fly using a just-in-time compiler for maximum performance. This layered architecture provides a stable, high-performance foundation for every Java application. While powerful, Java is known for its verbosity and explicit structure. Its syntax is C-family, meaning it uses curly brushes, semicolons, and familiar control structures. Key structural points include strictly class-based. Your entire program lives within classes. This structure encourages good object-oriented design from the beginning. The main entry point. Every executable application requires a public static void main string args method. This is a starting line where the JVM begins execution. Statically typed. This is a major difference from languages like JavaScript or Python. In Java, you must expli- explicitly declare the data type of a variable, int, for example, string, before using it. This strict typing helps the compiler catch many errors during the build phase, long before the program ever reaches a user, drastically improving reliability in large code bases. Where is Java actually today, used today? The breadth of its application is staggering. Enterprise backend systems. This is Java's traditional stronghold. Frameworks like Spring Boot have uh, revitalized Java, making it easy to build high-performance, scalable microservices and RESTful APIs that handle billions of transactions daily in the finance, healthcare, and e-commerce sectors. Mobile apps, Android. The foundation of the Android OS is Java. Although Google now promotes Kotlin, the entire existing Android ecosystem, including core libraries and services, is built on Java. A significant percentage of Android developers still rely on Java for new development and maintenance. Big data and cloud. Java is a foundation for major big data tools like Apache Hadoop, Apache Kafka, and Apache Spark. Its performance and resilience under heavy load make it a natural choice for processing petabytes of data. Furthermore, in the cloud era, its JVM flexibility and tools like GraalVM make it an ideal choice for serverless and containerized deployments. When we look at language rankings, Java consistently sits at the very top, while Python might lead in some indices, indices due to its dominance in scripting and data science. Java retains its dominance in the enterprise and server-side domains. This high ranking isn't just about developers using it. It's about the massive number of professional job postings, the extensive educational curriculum dedicated to it, and the sheer volume of existing code bases or legacy code that must be maintained and updated when reliability and performance scale are the absolute requirements. Java is a proven, stable choice that organizations continue to bet on. Java is C++ without the guns, clubs, and knives. James Gosling, creator of Java. Let's reflect on this famous quote from James Gosling. Java is C++ without the guns, clubs, and knives. This is a brilliant summary of Java's design philosophy. The guns, clubs, and knives he refers to are powerful but dangerous C++ features like explicit pointers and manual memory management. Pointers can lead to disastrous memory corruption, and manual memory management is complex and error-prone. Java took the power of OOP from C++, but removed these sharp edges, providing the garbage collector and strict memory access controls. The result is a language that is fundamentally safer, more stable, and easier to learn and master, making it suitable for team environments where millions of lines of code are shared. The Java of today is not the Java of the 90s, thanks to its rapid 6 months release cycle. The language is experiencing a renaissance. Two major projects are shaping its immediate future. Project Loom, virtual threads. This is a game changer for concurrent programming. Traditionally, Java handled concurrency using expensive operating system threads. Project Loom introduces virtual threads, lightweight, inexpensive threads managed entirely by the GVM. This allows Java applications to handle millions of simultaneous connections with minimal latency, making it hyper efficient for modern web services and microservices. GraalVM native images. GraalVM is an advanced VM that can compile Java bytecode into standalone native executables. This drastically reduces application startup time from seconds to milliseconds and lowers memory consumption. This optimization is critical for success in cloud and serverless environments where fast startup is paramount. Thank you very much for joining me on this deep dive into Java. We've covered its historical journey, its technical foundations, and its exciting future. We can clearly see why Java remains a foundational skill for any serious programmer. I hope this detailed overview was valuable to you. Please feel free to drop your questions in the comments below, and I will see you in the next video.